Okay, so now we are recording the support video for phase 5 of the bomb lab. I understand that this is being a difficult one for many of you, so we will start. This video is to support you on this. So as usual, we will start with opening JDB, the debugger on the bomb executable. Then we will introduce a break at phase 5. Then we will run using the solution.txt that we saw earlier. Spelling mistake here, so .text. So we got until phase 5, so I will try A, B, C, D, E, F, and you'll see later why I'm trying this for illustration purposes, and enter. So now we are in the phase 5 at the breakpoint that we introduced. So disassembling, you'll find that we have phase 5. So let's look into phase 5 and see what's going on here. So the first thing you can see is that we have two explode bomb statements, two calls for the explode bomb function. So here is the first one. So let's look into the first one and see what's happening. So you can see that this is happening directly after a call to a string length function. So obviously what we have here is a string. So the answer for this phase is a string. And we have a compare statement just after the string length between 6 and EAX, which shows that we are actually having a string length of probably 6 characters. If they are equal, we're gonna jump into phase 5 plus 1, 1, 2, which is here. So skipping the explode bomb. If they are not equal, and that means the number of characters in the string is not equal to 6, then the explode bomb function will be called and the bomb will be exploded. So this is the first thing that we note, is that we have 6 characters in the string. So let's move on to the second call for the explode bomb, and we can see here that we have a call to the strings not equal. So this explode bomb part of the program will compare two strings, probably one already stored inside the memory and one that we have entered, and if they are not equal, it's going to explode the bomb. So here we see that the two strings that are being compared are stored in ESI and RDI respectively. So it is worth actually looking into what is actually there in ESI and RDI at this point. So the best thing is to run the program until here and see what do we have stored in there. So what we will do is that we'll have an until and 0x and now it's time to test what do we have in there. So let's do it using this. So we'll start with ESI, and here we can see that we have FLYERS flyers stored in here. So I will go in here. So flyers is probably the string that we are comparing against, so I will store it in here, flyers, for us to come back to it. Then we'll do the same with RDI. So let's see what we have in RDI. So this is probably the string that we have entered after being manipulated, which is, so these two strings are not equal. So this is the A, B, C, D, E, F that we have entered, but after being manipulated inside the code. So we will enter it A, D, U, I, E, R. A, D, U, I, E, R. And our basic string that we entered is A, B, C, D, E, F. So obviously both strings are not equal, so if we proceed we'll find that we will enter into the explode bomb. So if you check it out, ni, and whoops, we have exploded the bomb. The bomb has been blown up. So let's now have a look into what's going on inside here before the strings not equal call function is being called. So we can see here that we have, if you look carefully into the code, you will see here we have a jump if not equal instruction that jumps into 5 plus 41, which is here. So here we see that we have a loop that goes around. So we have a compare statement between RAX and 6, and if they are not equal we're going to go back. So the only way we are going to exit this loop is after 6 times. We have an increment to RAX, so every time it's incremented by 1 until it gets to 6, and then we exit the loop. So obviously what's happening here is that this string, we have 6 characters, so each character is being manipulated at one iteration of the loop. So we have 6 loops, 6 iterations in the loop, and we have 6 characters. Each character is being manipulated or changed in one iteration of the loop. So the best thing to do is to see what's going on inside in order to see how did ABCDEF be changed into ADUIER. Now flyers is now obviously there's something going on, that there's a cipher or encryption going on that converts ABCDEF into this. So what we need to know, we need to understand how are we gonna have flyers being converted to from the original character. So we're gonna reverse engineer it. So by looking into what's going on inside here. So if we look carefully here, we will see what's happening here is move ZBL. So what this does is that it takes RBX is the value that we have entered. So here if we start with the first iteration, so this will be A, RAX will be 0 because that's the counter, and RAX multiplied by 1, which is this is the scale. So if you remember the equation that we did in the lectures, so RAX times 1 plus RBX, so that's 0 because RAX 0 multiplied by 1 is 0, plus RBX is A. And A, the way it is stored in RBX, you will see that it's stored in ASCII code, and you would expect that the ASCII code for A, so this is a table that I got from the internet, so A is 97. So let me just run the program and see what's going on in there. So I'll run the program until this point, and then we'll go through one iteration and see what's going on here. So I'm going to run it until here. And I'm gonna enter ABCDEF once again, and now we are in phase 5. So I'm gonna run until here. So if I check what's going on in here using the information register command, you'll find that RCX is so what we have here is ECX is having the value of RBX plus 0, and RBX is supposed to be A. So if we check RBX, you can see that RBX is a memory value here. So if we look into what we have in RBX, so RBX, you'll find that we have A, B, C, D, E, F. So that's the value we enter. So the first value in RBX is A. So that is the value we have in RBX at C0. So that's 97. So if we execute this instruction, so something will change in ECX, and if we check the registers, you'll find that ECX becomes 97, which is the first value of RBX. So the next instruction, so if we disassemble once again and see where we are, so we see that we are now in the next instruction here, which moves CL into RSP. Not really, it doesn't do much here. Here we see that RDX takes the value of the stack pointer, of the value that's stored in this value of the stack. So let's actually go step by step and see what do we have in the registers. So here we have 97, RCX is 97, RDX takes the values that are there in the stack. So now we will have an NI next instruction, and then we will check what is there. Let's disassemble and see where we are. We are here. So here we have an AND statement which does an ANDing between 0xF and EDX. EDX was 97, or in hexadecimal it is 0x61. If we AND 0x61 with 0xF, which is basically 111, we will see that the first value here will be masked away, and the only value that will go through is the 1. So it's like we are ANDing 0x61 with 0x0f. So the 6 will be null because of the 0, and the 1 will go through because of the f. So it's like we are masking. So what I would expect after this instruction is executed is we are gonna get probably a 1. So that's what we have here. So this is the outcome of ANDing 0x61 with 0x0f. So let's move on and see what is there in the next instruction. So the next instruction here is move ZBL. So this moves a value that is stored in this memory location plus the displacement that is there in RDX into EDX. So what we have in RDX from here is 1. So the only thing that we need to understand, to know, is what we have inside this memory location. So let's investigate that and see what we have in there. So we will do this. I need to look into the 16 values. You can do 16, 8, but my guess is that 16 is good. 16 characters that are stored in this memory location. So 0x4024B0, which is this memory location here. Oops. So here this looks interesting because this looks like the key to everything. So I have an MADUIERSNFOTVBYL. So if I just copy this up, I'll copy this and put it into my text file here for reference. So I have MADUIEL. So the first memory location at 0x4024B0, I have an ASCII M stored in there, which is 109. If you want to double check, so you'll find that M is 109. So if I go back here into my code, I can see that what's happening is that I'm going to add the value of RDX plus this memory location. So the displacement that I have is basically 1 from what we saw in here. So RDX is actually 1. So we are having 1 plus the base location, base memory location. The base memory location is M, so this is 0 and this is 1. So you would probably see that the first memory location, so what happened to my A here, to my A that I have entered in here, what happened to my A has been changed into A here once again. So this is what happened, because my original A caused after looking into the code and the decrypting was going on, so you can find that we are adding 1 to the base location, so that's 97. So if I want to proceed to the next iteration of the loop, so I will go like this, and what I will do is, the best thing to do is to again do an until 0x409, so such that we can test it. Sorry, I will do it until here, such that we can test it once again. So actually I should have moved until here only. Yeah, so the output of the second iteration is 100. So if we look into the text file, we will see that the B has converted to a D, which is 100 in ASCII. So now the next iteration we will see, so I will move the next iteration into this location here, such that we can see what's going on in here. So we have until, and we'll paste this. So now this is the third iteration, and if we look into what's going on inside, we will see that we have RCX is 99 or 63 in hexadecimal, and 63 in hexadecimal is, or 99 in decimal is, 99 in decimal is C. So that's what we would expect from the third iteration. And here we have a displacement of 3. So after running this, after executing this statement, so we will have 3 as the displacement from this memory location. So if we do if we look into the memory location once again, so we'll find 0, 1, 2, 3. And you can find that we have the output is actually U. So that's what we actually got against the C. So C has been converted to a U, and we can confirm that after running the instruction itself. So after running the instruction, we can see that RDX became 117, which is basically U. 117 is a U. So if we continue running the loop, the loop for 6 times, what we will get is ADUIER. So that's where the conversion takes place in here, from ABCDEF into ADUIR. So how do we get to flyers? So probably the best thing to do is to understand how do we get to an F. So I'll just do the first one and then I will leave it up to you to continue. So in order to find the final solution that actually does this mapping between each value here and the expected value, we would probably have to go back to the ASCII code, and before the ASCII code, if we check what's the displacement that we need in order to get an F. So that's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So in order to get an F, we need a displacement of 9. So if we look into the code here, any character that has the second hexadecimal number to be 9 will be good enough to dismantle the bomb. So here we have 0xF. If we have a character that will be that will have an output from here equal to 9 from this statement, 0xF EDX, any output from here that is equal to 9 will solve the first phase, the first character. So if we look into our ASCII code here we have hexadecimal digits, and I can see here we have number 9, which has a decimal value of 57, and the hexadecimal value of 39 might do the job. So what I will do here is that I will check whether that will work or not. By running the program once again. And I will start by having the digit 9, A, B, C, D, E, F. And I will enter. So if I again go until the beginning of the loop and see what's going on in here, so I will disassemble, and now I am in the beginning of the loop, and then I will check the registers. So I will move on. So here I have the character 9, which is 57, and this is 0x39 into RCX. So this is where I am. So now I will proceed with the program, and I will proceed with the program until I get into here. So another NI, disassemble, and now we are here. Let's check what we have in here. So we have 39 in RCX and we have 39 in RDX. After this statement, we should expect that we have a displacement of 9. So the output is EDX will be 9. You should expect that. So if I run it and then I check it, and you find that RDX is equal to 9. So that's good enough in order to convert our 9 into F. That is what is required. So now we are under this statement here, and we should expect after executing this that we are going to get an F. So I will move on. So we executed this instruction, and if we check it out, we'll find that we have 102. RDX is 102. So let's check what's 102 in here, and 102 is F, exactly what we need. So now we have converted the first character into the destination character that we need. So we have converted, so 9 has been this, instead of A we have a 9, and this 9 is equivalent to the F that we require. If you repeat the same for all of the other characters here, you change the B accordingly in order to get an output of L, and C to get an output of Y, and D an output of E, and E an output of R, and F an output of S, you will get your bomb dismantled. So I think that's good enough for this video. Please let me know if you have any further questions.